Okay, so let's look at tutorial 3, part 2. So given the same data as the first part, we're asked for the compressive strength if a force of 30 kilonewtons broke the sample, and briefly comment on the meaning of the result. Okay, so we have strength. That's indicative of a stress. So if we had our material again, like this, stress, strain, we put it under some compressive load. It has an elastic region, then it has a plastic region, it has a maximum, which is in this case the ultimate compressive strength, CS. Okay. So this is what we're talking about. So this will be in newtons per meter squared for the base, or pascals, which are the same thing. It could be in megapascals or gigapascals. Okay. So that's what we're looking for. Okay, so stress is equal to force over cross-section area. And so that, of course, is where this comes from. Okay, area, meters squared, and force is in newtons. Okay. So we want to find the stress is 30,000 newtons. Okay, so given the force divided by cross-section area. So are we given the cross-section area? Well, we are, but we're not given it as meters squared or anything. We're given it as the dimensions of the sample. So the dimensions are 10 millimeters by 10 millimeters by 100 millimeters this way, okay? Let's assume that our compressive force is going this way. So the cross-section area is 10 by 10. Okay. So let's just do that over here. So we can convert 10 millimeters into meters, which is 0.01 by 0.01. Okay. That comes out as 1 by 10 to the minus 4 meters squared. So if you put that in here, you calculate it out, you'll come out as newtons per meter squared. You can also, just so as you know, do kilonewtons over millimeters squared, and it comes out as megapascals. Just a little shortcut, okay? But if you're not that comfortable with it, stick to the base units and it'll make things easier. Okay. So 30,000 divided by 1 by 10 to the minus 4. That will come out as 300 by 10 to the 6 newtons per meter squared. Okay, so again, we may be asked in a different unit. Newtons per meter squared are fine. That's also equal to 300 by 10 to 6 pascals. Pascal is a Newton per meter squared. 10 to the 6, as we saw in the other one, the previous example, is megapascals. So that's also equal to 300 megapascals. Okay, which is our answer. So then finally, we're asked about the meaning of that result. So we have 300 megapascals of compressive strength. We have 220 megapascals tensile strength. Therefore, the compressive strength is greater than the tensile strength. So what kind of a material would typically have a compressive strength greater than tensile strength? Well, typically that would be ceramics. Okay. So it's quite possible that this material is a ceramic.